In this video, we're going to check, does a point satisfy the system? First, we need to set the equations equal to each other and substitute a value from the given coordinates into the equation. Next, check to see if the equation is a true statement. When you simplify it. The other thing to note is that both sides of the equation will be equal to each other, and the output, or the value on each side, should be the other value in the coordinate point. So let me show you what I mean by that. An ice melt product at a specific time of year is modeled by the demand equation y equals negative 10x plus 100 and the supply equation y equals 5x plus 550. Does 3700 satisfy the system? Since we're given a coordinate point, we assume the first value is x and the second value is y, and we set our two equations equal to each other. Since they both equal y, we can do that. So negative 10x plus 100 equals 5x plus 550. Now we take the x value from up here and we substitute it in for the x's in this equation. Negative 10 times 30 plus 100 equals 5 times 30 plus 550. Now, we are not sure if this is a true statement, so we have to check to see if we get a true statement when we simplify both sides. Negative 10 times 30 is negative 300 plus 100 on the left, and 5 times 30 is 150 plus 550. This simplifies on the left to negative 200, and on the right simplifies to 700. Now I want to point out something. If I color code my equations, this 5x plus 550 was on the right side. And if I change colors, this other equation, negative 10x plus 100, this was on the left side of my equation when I set them equal to each other. So I want to show you that the left side, when we substitute 30 in, we do not get 700 out. But on the right side, we do get 700. This means that this solution is true for one of the equations, but not the other. And so if you substituted just into one of the equations and not into the system, you could hypothetically get one equation that's true, but the other one would not be true. That's why you want to set them equal to each other. So since this equation that we generated does not equal 30, 700 is not a solution to the system. In example 2, the demand for apartments is modeled by Q equals 100 minus 5p. The supply equation is Q equals 50 plus 5p. Does a value of 5 for p and a value of 75 for q satisfy the system? First, we're going to choose 10 minus 5p on the left, and we'll go ahead and do 50 plus 5p on the right, so we can keep track of which is which. 100 minus 5p equals, and we're trying to see if this works, 50 plus 5p. And now I'll replace the p with 5. 100 minus 5 times 5. And we want to see if that's equal to 50 plus 5 times 5. 100 minus 25 equals 50 plus 25. We need to see if that's a true statement. On the left we get 75, and on the right we get 75. This is true. So yes, this is a solution to the system. And also, notice that this number here for Q is the number we got for both sides of the equal sign. So this point that we used, 575, is where the two lines, if we were to graph this, intersect.